Hi everyone, this is Professor H. Rahman from Agriculture and Food Engineer Department, IIT Kharagpur. I welcome you all to this NPTEL online course on traction engineering. This is the lecture 15 where I will try to take a tutorial related to rolling resistance. That means how to find out rolling resistance of a rigid wheel as well as a pneumatic wheel. So, the concept will be how to find out rolling resistance of a rigid wheel on a horizontal as well as inclined surface, how they are different, and then finding out the rolling resistance of a pneumatic wheel. When I said pneumatic wheel means there will be two modes of operation, one is rigid mode and the other one is elastic mode, and how to find out rolling resistance in these two modes of operation, that we are going to discuss with the help of simple problems. Now, if you look at the problem which I have given here, if a free rolling rigid wheel of diameter 80 centimeter, section width 10 centimeter and the total weight 10 kg, this has to be operated on a horizontal surface with shear deformation modulus 2000 Newton meter raised to the power n plus 2 and exponent of sinkage as 0.5. Under these conditions, you have to find out what is the force required to tow the wheel. So, the informations which are given are very clear. One is diameter, which is given as 80 centimeter. The other one is section width, which is given as 10 centimeter. B is given as 10 centimeter. And weight which is acting on the wheel is 10 kg. Now, if a wheel is there and we want to find out the rolling resistance, this is a horizontal surface as I said. So, then the first thing is what is the sinkage and what equation you are going to utilize. Since the diameter is more than 80 centimeter, so we can conveniently apply Baker's equation for finding out rolling resistance. So, which is nothing but R is equal to B K Z0 raised to the power n plus 1 by n plus 1, and we are interested in, because Z0 is not known. So, we have to find out what is the value of for Z0. Now, this is W. Okay. So, expression for Z0 will be, if you look at the Baker's equation. So, Z0 is nothing but this will be equal to 3 W by B K square root of 2 R into 3 minus n raised to the power 2 by 2 n plus 1. Now, in the problem, the value of K is given, shear deformation modulus. So, K is given as 2000 Newton meter raised to the power n plus 2 and exponent of sinkage n is given as 0.5. So, now you have to substitute these values. That means, weight is given, K value is given, B value is given, diameter, that is 2R is given, 3 minus n is given. So, now you substitute these values and find out what is the value for sinkage. So, once you know sinkage, you substitute in this equation rolling resistance is equal to B K Z0 raised to the power n plus 1 by n plus 1. So, you will find out the value of rolling resistance. So, rolling resistance is nothing but the force required to tow the wheel. So, that is will be the force required to tow the wheel, and it comes out to R, or the towing force comes out to 71.178 Newton. Since weight is less, sinkage is less, so obviously the rolling resistance will be less. So, it is basically the first thing which you look into this is this a rigid wheel, free rolling rigid wheel, and there is no power. So, it is a towed wheel So we immediately apply Baker's equation, but in Baker's equation there are certain limitations which are to be looked into. So limitations is sinkage should be low and the diameter should not be less than 50 centimeter. So that way it is satisfying. Diameter is 80 centimeter and sinkage you can verify from here and then apply Baker's equation to find out what is the rolling resistance. Now next thing is, if the same wheel is to be towed up on an inclined surface, that means now the surface is no more horizontal, so it has been inclined. So the new setup will be like this, and this inclination is given as 15 degree. What will be the force required to tow the wheel up the slope? So for this you have to draw it. This is the wheel. Now weight I said 10 kg, so it will have two components. So this is theta, so this component will be W cos theta and this component will be W sin theta. I want to move the wheel upward against the slope. So what to do now? We have to find out again, because this wheel is satisfying Baker's theory, that is rolling resistance theory. So we will use the same equation. B R will be equal to Bk Z0 raised to the power n plus 1 by n plus 1, but this is only for horizontal surface. Now since the surface is inclined and there is a component is acting along the slope W sin theta against the direction of travel, opposite to the direction of travel. So that means the rolling resistance will be no more the expression which I have given for horizontal condition. So rolling resistance will be Bk Z0 raised to the power n plus 1 by n plus 1 plus W sin theta. So this is the additional component which will come into picture. Now what is Z0 in this case? How to find out Z0? For a horizontal hull surface, we calculated Z0 is equal to 3W by Bk square root of 2R into 3 minus n raised to the power 2 by 2n plus 1. Okay. Now, but in case of an inclined surface, what is the weight which is acting here? We have to take that into consideration. So instead of W, we have to take W cos theta. So that means Z0 will be equal to 3W cos theta by Bk twice R 3 minus n raised to the power twice upon 2 by twice n plus 1. So the difference is, instead of W which we have taken for horizontal surface, this is for Z0H horizontal surface, this is Z0I for inclined surface. So this difference has to be incorporated, then only we will find out what is the corresponding sinkage. Now in this equation we can write this as rolling resistance is equal to Bk Z0I raised to the power n plus 1 by n plus 1, okay, plus W sin theta. So B is known, K is known, because these are not going to change, and exponent of sinkage is not going to change. So W sin theta, we know theta, so you can calculate W sin theta, and then immediately you can find out the Z0 I value, and then substituting in this equation, this will be the final value which is required to tow the wheel upward along the slope. Now if somebody will say I will move this one downward, then the difference will be how much? So, instead of plus w sin theta, because we are rolling it the opposite direction, so this will be minus w sin theta. Okay? So, that is the difference. This component is acting downwards, so it will be minus because we are rolling downwards. So, these are the difference we have to take into consideration. I hope I have clarified in the sense first we have to see whether the conditions which are given are applicable to the Baker's limitations which are given within that or not. If it is satisfying, then you take the help of Baker's equation and the derivations which we have already done for sinkage, that you take and find out, and from that sinkage then find out what is the rolling resistance. And if it is an inclined surface, then look at the first you have to draw it very neatly and then see whether we are moving upward or downward, because that W will be now resolved into two components. One is horizontal component, the other one is vertical component, and that vertical component is responsible for developing that sinkage. So, the vertical component will be W cos theta. So, instead of W you have to replace with W cos theta, and if you are moving upward then the horizontal component has to be added, and if you are moving downward then the horizontal component W sin theta is to be deducted. So, this is all you have to keep in your mind, then only you can solve this problem. Now, next problem is a two-wheel drive tractor when it is fitted with 13.628 tires at the rear axle carrying a load of 15 kilonewton, and this has to be operated in soil with a pressure sinkage parameters, exponent of sinkage n as 1, frictional modulus of sinkage k phi 1520 kilonewton meter raised to the power n plus 2, with both the wheels sharing equal load. Then two inflation pressures 70 and 100 kilopascal are proposed. Now, the corresponding pressure due to carcass stiffness is 20 and 35 kilopascal respectively. So, what is asked is to find out the rolling resistance of rear tires for both the conditions, and then from there you have to suggest which inflation pressure is to be used. So, when I said it is a pneumatic wheel, so the first thing which you have to look into is what is the mode of operation. There are two modes of operation. One is rigid mode, the other one is elastic mode. If it is rigid mode, then you have to follow Baker's equation. If it is elastic mode, you have to follow other formulas which I am going to derive, which we have already derived in our theory classes. So, to find out the mode of operation, we have to first find out what is the critical ground pressure. What is given? N value is given, N is 1, K phi is given as 1520 kilonewton per meter raised to the power n plus 2. Since Kc value is not given, that means Kc is assumed to be 0. So, K phi value K is equal to Kc by B plus K phi. So, now since Kc value is not given, we assume as to be 0. So, this component will be 0. Now, K phi will be equal to K. Now, for finding out the critical ground pressure, so we denote it as P G critical GC, GRC. So, this will be equal to K raised to the power 1 upon 2n plus 1 into 3w by 3 minus n into b raised to the square root of d raised to the power 2n by 2n plus 1. So, k value is known. What is unknown is this section width and d and w. W is given. So, the axle has to carry a load of 15 kilonewton. So, W will be equal to 15 by 2, and the other thing which is given is both the wheels are sharing the same load, that means equal load. So, that is why I have divided W as axle weight divided by 2. So, that way you get 7.5 kilonewton. Now, to find out B and D. So, the tire is a bias ply tire, and since no aspect ratio is given, so we assume that aspect ratio as 0.75. So, now find out the section width B and diameter D. So, section width B will be equal to how much? It is given as 13.6. So, 13.6 into 2.54. So, that will be in centimeter, and for finding out D, we have already given that formula in the theory class. It is 1.06 times nominal rim diameter, which is here 28. This is in inches, so I have to convert it into centimeter or meter, then plus 0.75, which is the aspect ratio, into 2 into 13.6. into this is in inches, so again multiply with 2.54. So, that way we will get a diameter of 1.27 meter. Okay. So, D is now calculated, B is calculated. Now, substituting here you have to find out and exponent of sinkage is given. So, this comes out to be 100 kilopascal critical ground pressure. Now, two inflation pressures are suggested. One is 70 kilopascal. So, Pi is 70 and corresponding carcass stiffness is 20 psi. So, Pc corresponding to 70 is 20 kilopascal. The other condition, Pi is 100 kilopascal and Pc is 35 kilopascal. So, Pi plus Pc in the first case is 90 kilopascal, and in the second case Pi plus Pc will be equal to 135 kilopascal. So, if you compare with this critical ground pressure, in one case it is lesser, the other case it is higher. So, in the first case where the Pi plus Pc is less than 100 kilopascal, that is 90 kilopascal. So, I can write critical since Pi plus Pc is less than critical. So, the tire will be deflected and it will be operated in elastic mode. So, elastic mode. So, Z0 will be equal to Pi plus Pc, that is the pressure which is prevailing in the contact area. So, by K raised to the power 1 upon n, and then the rolling resistance will be equal to B K Z0 raised to the power n plus 1 by n plus 1. This is the condition when Pi plus Pc is lesser than critical. So, now the second condition says 100 plus 30, 135, that means Pi case 2, this was case 1. So, Pi plus Pc is greater than P ground critical. So, the tire will behave like in rigid mode. Okay? That means it will behave like a rigid wheel. It will behave like a rigid wheel. So, as you know, rigid wheel Z0 will be equal to 3W by B into 3 minus n square root k square root of d raised to the power 2 by 2n plus 1. Okay. And d is known, k is known, n is known, b is known, w is known. So, you can immediately calculate Z0, and then again putting the value, rolling resistance will be equal to B k Z0 n plus 1 by n plus 1. Okay. Now, this is the rolling resistance for a single wheel. If you want to find out rolling resistance of rear tires, so that means this has to be multiplied with 2. Same is the case here, multiply with 2. Now, you verify where the rolling resistance is more, then accordingly we reject that one. Where the rolling resistance is less, that has to be taken, and then that corresponding to that, what is the inflation pressure, that has to be recommended for continuous operation. So, while calculating the rolling resistance, there are two things to be seen. One is what is the mode of operation. Once you decide the mode of operation, that means we have to first find out what is the critical ground pressure, and then knowing the inflation pressure and the pressure due to car car stiffness, if the sum of these two pressures are lesser than the critical ground pressure, then we say that the wheel is operating in elastic mode. If it is more than critical ground pressure, we say that this is operating as a rigid wheel. So, if it is under rigid wheel, then we apply Baker's equation to find out what is the rolling resistance, and if it is in the elastic mode, then we first find out Z0 shrinkage, taking into consideration the sum of inflation and carcass pressure and the modulus of shrinkage, and then from there we find out what is the rolling resistance. Hope I have clarified this problem. So, in brief, I can summarize. In this tutorial, I tried to cover the concepts of computing rolling resistance on a horizontal as well as inclined surface, where how to take the component of weight that is important in an inclined surface. So, once you decide that, then it becomes easier for you to calculate the rolling resistance. So, if it is rolling down, then the component, that is sin theta component of W, has to be deducted. If it has to be rolled up, then the cos theta component is to be taken up. Similarly, we try to discuss about the rolling resistance of a pneumatic wheel, where we discuss what is the rigid mode, how to find out rigid mode, then what is the elastic mode, and how to decide that the wheel is in under elastic mode. And once you decide that, then following the equations which are given, you can find out what is the rolling resistance. So, the inflation pressure and the car car stiffness, pressure due to car car stiffness, which gives minimum rolling resistance, that has to be recommended for using in the tractor. Thank you.